Now we're ready to develop an analytic or an algebraic description of a circle. That is, we can develop an algebraic equation that defines a set or a locus of points that's consistent with the classic geometry definition of a circle. So our definition starts off the same way the classical geometry definition does. A circle is a set of points a fixed distance from a fixed point. So I've got an arbitrary point here to be our circle center, and I'll call its coordinates h comma k. Now, if we draw a circle centered around that point, we can also draw in a radius whose length is r, connecting the center to the edge of the circle. Again, at an arbitrary point that I'll call x comma y. Now, this is all we need to come up with a formula. The distance formula tells me that the distance between these 2 points is the square root of x minus h squared plus y minus k squared. And because those 2 points are the center of the circle and a point on the distance, a point on the circle itself, this distance has to be r. Now, there's our formula, right? And we could stop here, but it's customary to simplify this slightly by squaring both sides, which leaves us with r squared equals x minus h squared plus y minus k squared. And that is what's called the standard form of the equation of a circle. Now, I've got a result written out here with all the formal details. The equation of a circle whose center is at h comma k and whose radius is r is given by this equation, which is what we just described, right? And this version of the equation is what's called the standard form. Now, if we were to take these two parentheses parts and multiply them out, we would get a version of the general quadratic equation that we talked about back in the very first conic sections lecture called the general form of the equation of a circle. A, B, and C here can be any real numbers, okay? But a key point that I really want you to notice is that the coefficients of both the x squared and y terms here and here are both 1. And that's a key feature of the equation of a circle. If those coefficients were different, we'd get a different kind of conic section called an ellipse that we're going to be talking about later in the course. Okay, so now that we've got this formula in hand, in the next lecture we're going to take it out for a spin and see some of the things that we can do with it.